Hello everyone, this is my reverse engineering project where I reverse engineer a dry cell battery. Product research. Ever wonder why and how battery hold power and makes remote control cars work? How our iPhones, tablets, iPads, and Androids are being powered even though they aren't plugged to anything. To us kids, a battery is a portable source of power that we use on our gadgets and gizmos, but that's all. What really is a battery? A battery converts chemical energy into electrical energy by a chemical reaction. The concept of a battery might have been existing even before the discovery of electricity by Benjamin Franklin in the 1740s. Jars with the copper sheets rolled up on an iron rod was discovered by archaeologists that belonged to the Parthian civilization. 250 BCE to 250 CE. The copper and iron combination is a possible form of galvanic cells used as a battery. And just here are the notable years for the development of batteries. 1786. Frog legs and electricity. Luigi Galvani discovered animal electricity, which led to the idea and invention of a battery. 1800s. The birth of the voltaic pile. The voltaic pile is the first true battery that produced a stable and consistent current, invented by Alessandro Volta. 1820. The Daniell cell battery. 1838. The porous pot cell. 1859. The arrival of lead-acid batteries. 1866. The Leclanche cell, a carbon-zinc battery. Georges Leclanche invented a battery composed of zinc anode with manganese dioxide cathode wrapped inside a porous material. 1886. Carl Gassener's version of the Leclanche cell. Carl Gassener invented another version of the Leclanche cell, which has a solid design and provided 1.5 volts. 1899. The nickel-cadmium battery. 1903. The Edison battery. 1912. Lithium and lithium-ion batteries. Gilbert Newton Lewis started doing experiments on lithium batteries, but it was only on 1982 when Rachid Yazami discovered graphite anode and developed rechargeable battery prototype by Asahi Chemical in Japan. 1955. The arrival of alkaline battery. Uri discovered that making use of alkaline in batteries makes it able to supply greater energy and higher currents compared to zinc-carbon batteries. Sony was able to commercialize the lithium-ion battery in 1991. Device details. Battery is a device used to store electric power. The battery that I usually see sold in stores are cylindrical in shape and vary in sizes. It could be AA size, AAA size, D size, or even rectangular, or the shape of a coin in various sizes. Some of the most common uses of batteries can be found at home, from toys, flashlights, to rechargeable batteries in our cell phones, tablets, laptops, and more. Other places you'll find batteries will be in instruments in the medical field, from hearing aids to ECG, heart monitors. Military on their flashlights, radio communications, and vehicles. Batteries are nearly everywhere, even in the space station. They need battery to store the energy they collected from the sun. Over here is the battery. The cathode, or the plus, is the part of the battery that absorbs all the electrons coming from the anode. The electrolyte is the conductive substance that transmits energy through the cell. And to the anode is the part of the battery that gives up all their electrons. Here is when I me and my dad dissect the battery. First, we start trimming off some of the spots of the folds and stuff. And after that, we started trimming the side part. After that, we finally took off the metal jacket and found the shrink plastic sleeve, which covered the zinc can.
No.
Over here, the top right here is actually the carbon stick. Here's the bottom, and then there's the plastic removed. After that, you'd see this cardboard, and if you take that out, you would see the electrolyte mixture. If you take the stick here, this is what it looks like. And then there's the paste. After you take out the cardboard, here's what it looks like. Here's the normal paste. And then here's some parts of the batteries. Here's the metal parts, a paper part, 2 of them are plastic, and 1 is cardboard. Over here are the parts of the battery, which I'll give you a sec to stare at. Here are the professionals. The professionals that are involved in this device are the artists, scientists, and engineers. Artists are in charge of the creation of the logo and color branding, which can be seen on the outside cover of the battery, which you'd seen in the picture as a metal jacket. Engineers had to design the construction, size, and shape to fit specific applications of the battery. Scientists or chemical engineers figures out the best chemical mixture and elements to be used to create the desired flow or current that are needed, or the capacity of how much and how long the battery can provide the electric current. Batteries provide portable sources of energy for powering devices, so as simple as flashlights and toys to as complicated as cars, solar panels, and space stations. Dry cell is a common type of battery we see used at home, and it converts chemical energy, which is stored in the electrolyte, into electrical energy. This is the type of battery I tried to learn too. The basic parts of this kind of battery are anode, cathode, and electrolyte. On this experiment, I learned the flow of the electrons is from negative to positive. I also learned that aside from solar, wind, hydro, geothermal, electricity can also be generated through chemicals, thus the term electrochemical, which the battery uses. Since it's from a chemical, it can be designed as compact also, like the one used on our wristwatch. It could be as big as, the one used in cars and industrial batteries. Here is a sample battery circuit. Imagine this is an electron. When it goes through the path in the circuit, it goes through this light bulb and it lights up. Then it travels all the way to the cathode. Then there's more and more which travel back to the cathode. They never travel back though. After all of them are done traveling, that's when a battery dies. Here are the acknowledgements. I thank my mom for supporting me and helping me. And thanks to my dad, I was able to look inside the battery. I also thank my teacher who reminds us students to work on it, the science project, as well as telling us to ask for help when we need it. Thank you for listening to me, and that's all.